Hey everyone, in this video we are looking at the following SAT math problem to have our tip of the day. The problem reads as follows. In the provided figure, UVXY is a parallelogram and VWYZ is a rectangle. First and foremost, I feel like I've already read too far. Whenever you're reading a question like this one, I suggest that as soon as you get up to a spot like UVXY, I'm going to go right here. I'm going to look at the picture. UVXY. Maybe follow it with your pencil. You don't have to actually draw over it, but follow it with your eyes and your pencil. Pay attention to where it is in the picture. Document it before you continue to read. Is a parallelogram. Again, I got to a geometry word. I'm going to acknowledge, okay, parallelogram. That means that opposite sides are parallel. Opposite sides are congruent or the same length. Angles that are diagonal from one another, like this, are also congruent or the same measure. And VWYZ, all right, well, let's find that. VWYZ is a rectangle, okay? So if that's a rectangle, I could even go in over here, for myself, remember that, okay, well, that would be a right angle, so on and so forth, So opposite sides here are congruent, opposite sides here are congruent. So this guy over here is the same length as this guy over here. That guy and that guy are the same length. So, lots of different things we can kind of look at over here. I'm just marking up the rectangle for now. But, we'll get into more in a second. If Vx equals 14, now again, before I keep reading everything, I'm going to take each bit of information before I get to the end of the problem and label, write it down, and then build on it before I continue. So Vx, so all the way to there, is equal to 14 in length. Now, if that's 14 in length, so is this. So I'm going to go right ahead and label that 14 as well. If Vx equals 14, next it says Vz equals 6. Vz equals 6. So we're going right from here down. Okay, that line is 6 right there. So 6, we're talking about this line. So all right, I can't really see, but okay, that's 6. So if that is 6, and then that is 6, best as I could do. Okay, and UZ equals 2. All right, UZ is this piece right there. So if that equals 2, even if you're not totally positive of what rules allow you to decide things, just trust your instincts. If you're in Algebra 2 at least, trust your instincts. You're probably right, even though geometry sometimes breaks down your math esteem, but you're probably right. Now, that's the last thing before they ask us the question, but can I conclude more based on what I have before I read the question? That's very important. And if you're the type of person that gets very overwhelmed after you read a whole lot of things, and you're like, I don't even know where to start to get to that question because you're so worried about the end goal, this is a great strategy for you. Just read a little, go to the picture, label it. Read a little, go to the picture, label it, build on it, so on and so forth. So if this whole entire line is 14 and this little baby piece right here is 2, well, you should be able to conclude then that this piece from here to here, so VW, right, over there, must be the length of 14 minus 2, or in other words, that piece, VW, is 12. So 12 is going from V to W, and then that means it's also the length from Z to Y right there. Okay, terrible drawing. Okay, so Z to Y is also going to be 12. Now, you should, if you get really good at practicing SAT type of problems, you should already know what the question is without reading it, because you are given enough information to figure out the length of 12. So they're probably going to ask you, what is the area of the rectangle? And sure enough, it is what they're asking you. They're not going to ask you what the area of the parallelogram is, because you already have enough information to do that, and you don't need to do any extra challenging adventure type of work in order to find that. So if it was the area of the parallelogram, right, which this is not what that is, but area of, I'll call it sub P for parallelogram, the formula is base times height. It's the same formula as area of a rectangle. The difference here will be that the parallelogram, right, so here's my little parallelogram, the parallelogram has a base of 14 and a height of 6. Your base and your height, if you remember, always make a right angle with one another. And since this is a rectangle and it's within this parallelogram, we'll be able to kind of conclude right there that it is a right angle in that little corner. Okay, now, sorry, moving that all over the place, 14 times 6, if you're doing a non-calculator section, you can do something like 10 times 6 plus 4 times 6. So you're sort of using distributive property in reverse order. So then we have 60 plus 24, which is 84. So 84 would be the area of the parallelogram. Sure enough, 84 would be a choice, okay? Sure enough, 84 is a choice because people are going to find the area of the parallelogram and just circle it and move on with their lives. But if we did the rectangle only, all right, so that's just this part here, some people might go ahead and do something where they find the area of the triangles and subtract. You can do that, 1/2 base times height. So 1/2 6 times 2, it's 6 and 2 is 12, half is 6, right? And another 6 and subtract that from the 84, kind of crazy, when we can just do that the area of the rectangle will equal base times height as well. And here's my rectangle, okay, equals base is, what did we say? 12 times the height is 6. 12 times 6, honestly, is one that you should have memorized. It's 72. So you're done. The answer is A. However, the choices are kind of lame on this one, because if you already know that the area of the entire parallelogram is 84 and the only option less than 84 is 72, and you can deduce that the area of the rectangle is going to be smaller or less than the area of the rectangle, well, then you could just pick 72 and move on with your life. All right. Again, you could break up the 12 into 10 plus 2, 10 plus 2. So you could do 6 times 10 plus 6 times 2. And that would be 60 plus 12, depending, how much non-calculator support you might need as advice. All right. So one last thing to tell you before letting you go is, in geometry, when we name a polygon, the letters, if the image is not provided, the letters are always going to connect in the order that they're listed, and then the last letter is going to connect back to the first one. So when does that matter? Well, it's going to matter from time to time. So let me just take a quick moment to show you when that might matter. So if they name it a rectangle A, B, C, D, and you draw A, and they don't give you a picture, say you did this, A, B, C, D, and you're like, I like it like that. I want it to look like this because that's what I want. Well, you're wrong. You can't do that. And then they might tell you like the midpoint of BC connects to A. So if you drew it like this, well, the midpoint of BC is like the center of the rectangle, connects to A, and then they might ask you, what is the area of A? And let's say we name the midpoint E. I'm really like just making something up as I go. But area of A, B, E, B, E. Now let's do the area of, so it would really be there. So A, E, C, D. So then there's E, and you're going to be like, what? A, E, C, D. So confusing. It makes no sense. So again, you're told you have a rectangle A, B, C, D in the problem. Then you're told E is the midpoint of B, C, and that point is going to connect up to A. Okay. But if you don't draw it right, you're not going to get the right image. So what should it look like? Well, let's start over. Again, A, B, C, D, if that is a rectangle, you have to connect it A to B to C to D, and then the last letter connects back to the first. The midpoint of BC, so that means that piece and that piece are the same. Name it point E, connects back up to A right over here. And then they might ask you about the area of AECD, which is right over there. And, you know, we might be able to figure out then that it's like 3/4 of the whole thing, yada, yada, whatever other information they're giving you. But I just wanted to point that out because it is quite important so that when you're in a situation where you're drawing your own pictures, in this case, it was provided for you. If it weren't, you might have to think a little harder. And if you look at the picture, it is connecting U, V, W, X, Y, back to Z, and then to U. So if you went all the way around, you could get that right over there. So that's it for this example. Went a little longer than I really wanted to. Hope that you feel a little smarter. Dallas hopes you feel a little bit smarter, right? Tell them they did a good job. And I hope you'll be back for the next one. Bye.